mean, you can never be overprotected. That's right. I'm a double nerd. Okay. So here's the liquid. So do you notice? Does it look very calm? No. Some of you can see it's got like things are popping off of it. This liquid actually bubbling. We can contain it. We can contain it. We're scientists. Looks like a virus. I don't know. I have confidence. Okay. Now I'm gonna hold this up for a minute. You see what's happening? It's bubbling. It's popping. It's evaporating. So I'm gonna get a little bit more in there. And notice how, as soon as I pour it on the table, it's gone. That's because the temperature is negative 300 degrees and the air is 90. It's not going to stay as a liquid for long.
Come here on the floor game!
Yeah. Okay. Here we go. Stay in there, yes. You didn't do it right. Come on. Yeah. Give it a good smack. See? Got it. As long as you do it right, we can contain it easily.
I think I got it.
I thought we'd be able to contain it, and it turned out after we did the experiment, my theory was wrong. So what happens now? I have to update my theory. So that's what we do as scientists. We make a guess, and as we get more and more evidence that either aligns with our theory or goes against it, we change our next guess. And so now we know the pressure inside that flask is too high to contain the stuff. So I got another idea. So I tried to contain this liquid nitrogen inside of a container. What if I try to take the air that's that's nitrogen and try to put it inside the container? Can I do that? That's not working. Is there another way that I can try to put the air that's around us inside the container? Use a fan, that would work. You over there? A lid? Okay. A lid, but a lid only closes one dimension. Is there a way that I can get the air all around us and close it in any way? Can I capture the air and put it inside? Yeah.
I've got an idea.
Air capture device.
A very sophisticated device. It's a balloon. This balloon, I filled it with air from around us. And again, I said nitrogen is 70% of our atmosphere. And so that's 70% of the balloon. So actually, I'm going to choose a larger balloon. Who thinks this will fit in there? Couple of hands? Okay. Okay, I'm seeing a lot more hands now. People are getting confident of it. Okay.
Well, I don't know. If you try to put the lid on that, I don't think it's going to fit. Or, wait a minute. What the heck? So what happened there? We had a balloon that was full of air from our atmosphere, right? And it's made of gases like nitrogen, oxygen, carbon dioxide, and it was that air was putting pressure on the surface of the balloon and giving it its shape. Now, what happened when we put the gas in that balloon in the liquid nitrogen? What state of matter did it turn into? Water, almost. It turned into a liquid, right? Just like that liquid nitrogen is gas, but in liquid form because it's so cold. When we put the balloon in the liquid nitrogen, the air in the balloon turns into a liquid. And so the gas that's giving the balloon its shape is suddenly gone, and the balloon just crumples up. Look at that. Now, if we put the balloon in the air and it warms back up again, look what happens. The liquid inside of it will start getting warmer and warmer, and it'll boil, just like the liquid nitrogen that we showed you earlier. And as it boils, it turns back into a gas, and that gas exerts pressure on the balloon and gives it its shape back again. Now, we have an even more high-tech, sophisticated air capture device, even more powerful than a spherical balloon. Ladies and gentlemen, we have a hot dog balloon. And look at that. Just like magic, we can still fit it inside that small box because the gas inside is turning into a liquid. Who's hungry? Anyone want hot dogs? What's your question? What happened? I didn't see anything. Anyways, man, this all this experimentation, this gas and liquid, I'm getting kind of hungry. Do you mind if I take a break real quick? Just Oh, perfect. All right, I'll be right back. Dan's gonna leave the show for a minute. Okay.
So, I wanted to show another demo. So we're both physicists. Aren't you a theorist or an experimentalist?
I use telescopes.
Use telescopes, so kind of a mix. He takes data. I'm a theorist. I don't do a whole lot with data. I'm at a desk all day. But the university still has not given me a desk. So I thought about building one. So I brought this block, and I brought this nail. Did you bring the hammer? The hammer so I could build my desk. We don't have a hammer.
Wait, did you seriously forget the hammer?
What else could I use then? A banana? I heard it right away. Yeah. You forgot the hammer.
No, you forgot the hammer. No.
We have to show them something. We have to make sacrifices.
I doubted you. I thought we could put the cork on the bottle and contain the gas. I was wrong, so maybe I'm wrong again. All right, I'll give you my banana. You can use it as a hammer, okay? I'll admit when I'm wrong. Do you think this will work? Let's be good. Oh God! My breakfast.
Can we do any? Did anyone see anything else earlier that might make you think? Can I do something to the banana?
We already tried the banana. What more do you want from us? These kids are crazy. They just want more bananas. What the? Where did you get that one? Okay, do you think this will work? Let's try it. Look at that. So, what state of matter? We talked about liquids and gases. What state of matter is a banana? It's a solid, right? Now, when Daniel used my breakfast, my banana, to try to hammer the nail, that banana has a ton of water inside of it. Like most foods, fruits, veggies, anything like that, there's a lot of water. And so he was kind of basically hammering half with water and half with solid. But when we put the banana in the liquid nitrogen, all of the water and everything else inside froze solid, and it became a lot more stiff, allowing us to use it just like a hammer.
Now, this gave me another idea. If liquid nitrogen can do that to a banana, so Ansh and I, we like to play racquetball together.
Oh yeah.
And he's been beating me a lot lately. But I thought that I might have a way to beat him. So, where are the racquetballs? I'm thinking,
Think about it.
if I maybe put a a racquetball in liquid nitrogen, do you think I could beat him? Yeah, maybe some, okay. So if you think I can, think about why, for my hypothesis. If you think I can't, do the same. Why can't I? So we're gonna have a competition. You're gonna give us a countdown. I have masterfully frozen one already. So I'm gonna use a frozen racquetball.
Go ahead.
We're gonna make
We'll
a
see how well
competition.
that works.
Yeah. You sound doubtful.
I think I got this in the bag. I'm confident after my banana theory was proven correct. I think I got this. So if I'm going to try, if anything comes towards you, please do not try to touch it. So we're going to play a little game. We're going to try to see who can bounce the ball as high as possible. Now, I think my normal racquetball can do a pretty good job. But let's see if your frozen ball technique will yield any results. I'm doubtful. Can we get a countdown?
5, 4, 3, 2, 1.
That worked for me. So the benefit is that these warm up very fast.
How?
That did
Not work for me. So why did that not work for me? What makes a ball bounce? Let's get some questions back here, yeah? Midline, okay. Over here? Rubber. Okay, so what about rubber makes it bounce? Just elastic. It's very elastic. It's very bouncy. And so when the ball hits the ground, it's allowed to bend. And the air inside of it adds pressure to make it bounce back up. Now, what did I do to my ball? Why might it be less bouncy? It's hard. All of the springs, all of the elasticity of my ball, it compressed. It became a little bit more rich, a little bit more solid. And so when it hit the ground, rather than bounce, it wanted to break. And so that's why you won the competition, I think.
And because I'm the greatest to ever do it.
I'm gonna beat him next time. So we've talked a lot about pressure. So we're gonna move on a little bit from the liquid nitrogen. But what if I told you that the air around us, just like the air inside the balloon is pushing pressure on its surroundings, what if I told you all of the air around you all the time is pushing on you? Would you believe me? Yeah? Yeah? We call that air pressure. This constant bearing pressure down on you. What happens if I took all of the air out of this room? Well, I guess we're not in a room anymore. If I took all of the air out of the earth, what would happen to us? Okay, okay. We need air in our lungs. But I don't want to do that. I think I like all of us being alive here. So we can, however, take all of the air out of a container, out of a vacuum chamber. So if I put a balloon inside there, what do you think would happen to the balloon? Okay, some